The final presentation in today's session, A, is by Bruce Roth with GAI Consultants, and he is going to be speaking about the Mount Washington landslide. So please, Bruce, take it away.
Good morning. I believe I'm sharing my screen and I'm able to be heard. Is that true? Nod your head.
You're good, Bruce.
Yep.
Okay. Thank you. Okay. Let's get going. I'm going to start my stopwatch here. GAI was the city's geotechnical consultant from 2010 to 2014. Most of the work involved small slides and wall projects. However, on the morning of April 8th, we received a call that a landslide had occurred on the north-facing slope of Mount Washington, which is downtown Pittsburgh area. The slide had occurred downslope of the businesses on Grandview Avenue and east of the Duquesne Incline. They asked that I come down and reconnaissance the site immediately. And so Nina Carney and I went downtown and we met with the city's representatives. My presentation this morning is going to focus on how we looked at the conditions of the slide. We researched the history of the area and also speak about the corrective actions and also discuss a press conference that we had. For those of you unfamiliar with Pittsburgh, you can see that the point here is in downtown Pittsburgh, and the landslide occurred on the south shore of the point. The point is the confluence of the Allegheny, the Monongahela, and the Ohio rivers. This is an aerial view of the site. In 2014, drone technology wasn't as developed as it is today, so we obtained a photograph from Hawkeye Aerial Photographs. It's a very large slide, so it's hard to really see, but some of the features some of the facilities that I wanted to point out are the Norfolk Southern Railroad, the Lamont Restaurant, and the Duquesne Incline. Now, when I was downtown, they requested that I attend a press conference that morning. And so in order to represent the profession honorably, I had to come up with some kind of way to answer questions. And fortunately, I had just recently attended a seminar by the Association of State Dam Safety Officials on risk communication and on strategies for addressing the media. And one of the topics that they presented was the message triangle. Message triangle is used so that you can answer any questions by diverting the answer to one of your messages. This is what Bill Clinton used in his 1992 successful run for his first term in office. Now, the three messages that I wanted to present was that geoprofessionals evaluate the stability of slopes and risks of site conditions. Public safety is of paramount importance, and that we follow an established procedure to investigate the landslides. So I'm going to break my talk up into these three topics, and starting with the geoprofessional evaluating the slope and what to look for during a site reconnaissance. This will sound somewhat like Jim's talk, this portion. And so When we arrived at the site, before we headed downtown for the press conference, Nina and I did a reconnaissance of Grandview Avenue, looking for cracks in the road and signs of distress in any of the buildings. And we did not see anything that caused us concern. So in our discussions with the city of Pittsburgh, it was decided that no evacuations were required. However, they did temporarily shut down the restaurant and also the Duquesne Incline. And then we looked at the slide and made some preliminary measurements and evaluations. And we saw that the west side of the slide had formed a rotational block of colluvium. And the scarp was roughly parallel to the incline and 50 feet to the east of it. The scarp extended up to and ran along a portion of the cliff face. The scarp is approximately 50 feet high on the western side and 20 feet high along the cliff face. We measured the slide to be approximately 800 feet long and 500 feet wide. Assuming the depth was approximately 40 feet, that calculated to an estimate of 500,000 cubic yards of material. This, another photograph of the slide. You can see this rotational block head scarp over here. This is the cliff face. A little bit more of a close-up of the rotational block. We classified this slide as a debris slide, which is when a mass of broken rock and soil moves downslope by sliding on a surface that underlies the deposit. And you'll see that there's many different classifications for slides. This is the work from Davies. A few more photographs of the rotational block. The scarp face. We noticed slicken sides and a view from the top. Also, approximately 2 weeks before the slide, a rock block had broken off from the cliff face. And when we arrived on site, we noted that water was running out of the cliff face onto the colluvium. We believe that the water from the cliff face had saturated the slide and the slide material that resulted in the displacements. We also noticed some drains that emptied out onto the colluvial mass. So the next topic will be our public safety concerns. And as we noted, there's 3 major facilities that were in very close proximity to the slide: the Norfolk Southern Tracks, the Duquesne Incline, and the Lamont Restaurant. So very quickly after the slide had occurred, the railroad was clearing the tracks. The tracks are Norfolk Southern's principal line, east-west line, and it runs from Harrisburg to Conway, Pennsylvania. An average of approximately 60 to 80 trains a day use the tracks. The tracks had been misplaced 1 foot vertically and 2 feet laterally. The tracks had been cleared and trains were able to use them within 24 hours. Within a couple of weeks, the railroad had performed some grading operations and installed a rock drainage channel along the perimeter of the slide. This is a photograph of the rock drainage channel. The rock drainage channel also picked up seepage from the cliff face and carried it around the slide material. The railroad also commissioned test borings, and within a couple of weeks, they had constructed a wall to prevent further displacements of the landslide. This wall is also very interesting in that it has a provision for tiebacks should they be needed in the future. We also coordinated with the engineers for the Lamont, and we looked at some of the old drawings, and we noted that the drilled shafts that support this portion that extends out over the cliff face are bearing in rock. We looked at any of the displacements, and apparently there was monitoring being performed, and so everyone agreed that the Lamont was not in danger of collapse. Within 3 days, they reopened the restaurant. We also worked with the engineers of the Port Authority who are working with the Duquesne Incline. The Duquesne Incline was being instrumented, so there was no movements detected from the slide. The Duquesne Incline is one of Pittsburgh's major tourist attractions, and it has been in service since 1877. It's one of 2 inclines that remain on the slope. A view from the top looking down, and the landslide would be on our right. Looking at some of the topographic maps of the area, this is the city's topographic mapping service. You can see that the incline was built on a point, a promontory point, and that the landslide would be over here in a basin bowl-shaped depression. So looking at the outcrops along the incline and how this was built and some of the information we obtained from the Port Authority, it was agreed that the incline was not endangered by the landslide. Then the next topic is message that I was able to direct all of my answers to was that geoprofessionals follow an established procedure to investigate landslides. And that begins with background research. Background research on mining, geology, previous landsliding, any existing borings, and our field reconnaissance and surveys. So looking at the stratigraphy of the site, this is a map that was created by Earth Inc., and it's at the incline, the bottom of the incline if you go. And you can see that Pittsburgh coal outcrops near close to the top of the side of the slope. And at the bottom of the slope, as Brian mentioned earlier, another marker bed is the Ames limestone. The Pittsburgh coal marks the bottom of the Monongahela group, and the Ames limestone marks the bottom of the Castleman Formation and the top of the Glensoft Formation. Associated with the Ames limestone are the Pittsburgh red beds, and as you get further into your careers, you'll hear about the Pittsburgh red beds several times. Since I'm getting close to the end, I'm going to skip this slide, but you can see some of the elevations of the different rock formations that I mentioned. History of the site was that they used to call Mount Washington Coal Hill, and it was where they would remove coal from the hillside for Fort Pitt. As we moved into a more populated city, by 1825, there was over 2 million tons of coal being used. And by the 1870s, about 13 million tons of coal were being used for the railroads, steel, and the heating industry. This is a view of Mount Washington. You can see how developed it is. The slopes have been stripped of trees to use for mining. Here's a picture of the goats climbing on the side of the hill. And also we looked at some old records, and we learned that there was a landslide at the same location back in 1938. Back in those days, they used railroad cars to block the landslide from further encroachment.
15 minutes, so if you can wrap up soon.
And we also will do. We also looked at the Pomeroy maps there, which are the landslide maps. We can see that historic landsliding is noted on the maps. A little bit about why we have a landslide here. Glaciers stopped north of Pittsburgh. However, a lot of the glacial material washed down and widened the river valleys and then later filled them in. But what we have is a condition where the rock slopes had been relieved of stress, and we call that the valley stress relief phenomena. And from that, we have a transitional slide, and as this material slid on the red beds, it just turned into rubble, and then that's where we would get future instability. So that's pretty much it. I'd like to thank you all for listening, and enjoy this beautiful day here in Pittsburgh. Thank you.
Thank you very much, Bruce. That's a great talk. I'd like to apologize again for our slight technical difficulties. We're going to have to truncate questions a little bit because they want to get back so Dick Gray has a chance to talk and some of the students have class. One question came in, said, what was the legal or contractual agreement that allowed the railroad to go into city property and perform the grading and channel installation work?
I am not a lawyer, but I believe the wall is on the railroad property, and also if anybody has worked with the railroad, they pretty much can, they have a lot of sway. The city did agree to allow them to do the grading, though.
Thank you. There's another question here. Is there any active monitoring of the slope for continued movement?
As far as I'm aware, no, except for the work that's being done on the Lamont restaurant and on the incline itself.
Okay.
One of the recommendations that we had for the city was that we form a panel that included all of the interested parties, the Port Authority, the restaurant, potentially PennDOT, maybe the USGS and the University of Pittsburgh. So as far as I know, that has not been taken any further. And a slide like this has a lot of impacts on all the neighbors, and I thought everybody should have a hand in deciding how things were going to be fixed in the future. So for now, it's just waiting for the next opportunity.
If there are other questions, please, we'll just keep trying to do this until we get called back. Do other people have questions? One question I guess I have, maybe it's for all of the presenters, is do you think that with the new modern tools, the communication of landslide risk is easier, or is it harder because there's so much more data for like the citizen to, or the policymaker to digest? What do you guys think about that?
I think it's easier for the geoprofessionals to evaluate the slides. I think the tools that we now have with the LiDAR and instrumentation are extremely helpful. But in terms of presenting to the public, I think having photographs and visual images are very helpful. So the LiDAR is good with that. But in terms of making it easier for the public to understand, I think you still have to be prepared with simple answers that are not too complex.